Yeah, greetings everyone. Welcome to today's session. Uh, Sorry, we had a bit of technical issues here and there we've been trying to solve. But we are now ready to go. So yesterday we were looking at land cover analysis. We did land cover mapping for 2025, and then we were not able to continue with the accuracy assessment because of some issues here and there. So today we will pick up from there. We finalize the accuracy assessment. We do some change analysis. We see how the ecosystem, how Mau area changed, the trend in land cover, and then we see what next can we do, because we had another activity that we were to do. If we won't be able to do it, then we will. I will give instructions in the e-learning platform for you to follow. In case you have a question, you will still reach out to us. We will be able to respond to them. So we go straight to ArcGIS Pro, hoping that you are able to follow what we did yesterday. So I'll start from classifying again the Mau ecosystem. So what we will do, I've already loaded the layer stacked image. So what we will do, we will go to imagery. Oh, sorry, let me share my screen. I hope you are able to see my screen. Okay, thank you. So now we go direct to classification. We will reclassify. So when I was troubleshooting to see where the error could possibly have come from, I realized that there could be an issue with the path. So today we will try to save the classification in the default folders so that we see how it is going to run. So this is the layer stacked image. So what we will do, we go to imagery, then classification tools, and then select training sample manager. So we have several classes in this image. So we will classify those classes. We might not classify all the classes. This is just for training purposes. We will use few samples so that we are able to finish within time. So maybe I'll start with the water body. So you click on the water, on the legend, water body, and then click on the tool. We have several tools here for drawing the training samples. So you can use any of them. Maybe let me use this for now. Another thing I realize also, maybe the number of training samples. So we need to have more training samples. So for this water body, maybe we can do, let's do around 10. Okay, we can do 10. I'll merge them. And then we train the forests. Forest, we have different shades of red, so we can have them represented. Okay, I will merge them. The other class is, sorry. The other class is the planted area or cultivated area. So we can have several samples again. I think those are enough for the planted or cultivated areas. We can have another class, maybe for the grasslands within the forest. Okay, grasslands, let me use these herbaceous. But remember, we said you can edit the legend to fit the classes that you are interested in. For now, for training purposes, I'll just use the ones that are there. But when you are doing your own classification, ensure that you change them to suit your needs. Maybe we can have that for this class. And then we save the training sites. I've called it MAU Training Sites 2025. Remember, we said you don't forget to indicate the year. So once you do that, go back to classification tools and click on classify. We can use support vector machine for now, but we said if you want to use random forest, it's also available. Yeah, when you open your folder in ArcGIS Pro and you realize that whatever you saved there, it's not visible, just click on this icon here. It's called a refresh. It will refresh the page and your contents will appear. So we can leave this default. And then for output classified dataset, we can leave it to save in the default folder. So the default folder, it's in your My Documents or where you save the project. So we give it some time to run. It takes, if the area is not that big, it will take around 2 to 3 minutes to run. Okay, that is our classification. It has successfully classified. So the next thing is now to generate the accuracy assessment points. So you go to Analysis, Tools. I'll close this. Click on Toolboxes. Scroll down to Spatial Analyst Tools, and then within Segmentation and Classification, you'll find the Create Accuracy Assessment Points. Now, select the classified image under Input Raster. And then for Output Accuracy Assessment Points, navigate to the folder where you want to save it. We can save it in the same folder and call it MAU Accuracy Assessment Points. Accuracy Points 2025, and then click on OK. So the target field, leave it classified. And then for the number of random points, now we said for the purpose of this training, we use fewer points so that we take the minimum time possible to run this. But it is advisable to have many points, because if you have many points, then the credibility of your data is a bit high. So for this, maybe we pick around 25 points. Again, yesterday we were using 20 points, and I've realized that 20 is too low. The minimum number of points you can use is 25. So let's try with 25. And then for sampling strategy, let it be stratified random sampling, so that it is able to distribute the 25 points within all the classes that we've used. And then you run, it's failing again. It just worked. Okay. Yeah, this is strange, yeah? The same error. But I did this today in the morning and it worked. I'm just wondering why. Okay, let me reclassify the image and then we see whether it will work. So go back to imagery, select the image. Yeah, let me reclassify the image. Go back to tools, classify, support vector machine, load the training samples. It is MAU training 2025. Number of training samples per class, we can leave it default. The output dataset, we can leave it default, same to the ECD file, and then we run again. Yes, it has run successfully. So we go back to analysis tools, create accuracy assessment points, select the classified image. Okay, I'll leave it to save in the default folder for now so that we see whether that is the problem. And then for the number of random points, maybe let me use 50, even though 50 is too many for this training, but let me use 50. Run. It fails again. Okay, this is strange. So maybe what we will do, we can go to the next steps, and then I'll try to find a lasting solution to this. Once I get a solution, I will record. I'll record and upload to the e-learning platform so that you are able to follow. So maybe we will move to the next step, because you can still proceed without the accuracy assessment. The accuracy assessment was to help us just know whether the classification is good enough for us to continue with it. But we can continue with it and then we assess the accuracy at a later stage. So we've just classified 2025. We need to classify another year. In your folders, you have a stack for 1995. So you can load 1995, we classify it again, and then we compare the changes and see the kind of analysis that we can draw out of that. So we have 1995 now. I hope you have it. So once you load, you go back to the same procedure, imagery, go to classification. You need to click on the image in the contents so that it activates the relevant tools. Image classification, training sample manager. So for 1995, we have different shades of forests. So we can start with forest. Okay, let me use this. These are forests. These are another forest with a different reflectance. So do several training samples. Especially for different shades. Remember we said for the near infrared false color composite, Deep red represents healthy vegetation and most probably a forest. I think these are enough for forest. We can merge them and then we train cultivated areas, planted is the same tool. Have several training samples. I think those are enough for that class. Now the other class could be, we used herbaceous. Yeah, we can use herbaceous. So have several of them. Have as many as you are able to identify them on the image. I think we can have that for now. Any other class that you are able to identify? Yeah, let's use those ones. Maybe we can add another herbaceous to just make them 10 or 11. Yeah, that should be enough. So let me merge the herbaceous. Yes. Now we have our training samples. We save them again in the same folder, but call it MAU training 1995. Yes, go back to imagery, classification tools, classify, support vector machine is okay. Browse to where your training samples are. Again, you see the training samples that we saved are not in the folder, but it's because we have not refreshed. So if you refresh, you'll be able to see them. Load it. Okay, we can save it there. Just save it in the default. And then you will export it to the right folder. So you give it a few minutes. There it is. So we now have our two images classified. Maybe I will export this to another folder so that we put them in a common folder. Classification, MAU. I call it MAU classified 1995. Save it there. Maybe we save it as TIFF. Output format, select TIFF. Then leave everything else as default and then click on export. Oh, okay. Not default. We need to set the no data. Let me remove this. Data export. Oh, it's as TIFF. Maybe I'll change the name here. I'll change the name to version 1. The output format is TIFF. Go to no data, put 0. And then everything else should remain as default. It has exported. This is our exported file. So I can remove this. Then you also export 2025. Save it in the same folder. Call it MAU classified 2025. Again, set the no data value to 0 and export. Yeah, now we have our two images, 1995 and 2025. Now we can go ahead and look at the changes that happened between the 2 years. So back to imagery, click on change detection. So use the change detection wizard. So there is a categorical change. Maybe we use the pixel value change. Remember, we said raster images are represented in terms of pixels. And we said classification is assigning pixels, values to pixels, or land cover classes to pixels. So we are looking at the changes within the pixels. And then from raster is the initial year. So that is 1995. So it is from 1995 to 2025. And then processing extent, just leave it to full extent. Click on next. So it is giving you the classes, just a preview of the classes within the different classified images. For example, 1995 has forest, herbaceous, and planted. 2025 has more classes. It has additional of a water body. So at this point, you can check the classes that you wish to analyze changes for. For example, if you are only interested in knowing the trend within the forest land or what has been happening to the forest, then you can just select the forests. But now for this exercise, let's use all the classes. We want to see the changes that happened within all the classes. So click on next. So for smoothing, let us not smooth, let it be none, and then save result as a raster dataset. And then now you select where you want to save your change, your output data. Maybe MAU change. I'll call it MAU change 1995 to 2025. But remember, don't use space when you are naming the files. So instead use underscore .tf here, and then run. So give it some time. Yeah, there it is. Now we have our image for the changes. So the areas that changed from herbaceous to forest, you can change the color. Just maybe let me change. No change. No change. I give it purple. So these are the areas that did not change. So herbaceous to forest. So these are areas where we had an increase in forest cover. You can give it a different color so that you're able to identify the areas. So these are the areas. But then you need to go further and verify whether these are real changes or there was a problem in classification. And that's why we were trying to do accuracy assessment to ascertain that whatever changes you are moving ahead with are true changes. So for this class, the herbaceous to planted or cultivated, most of them could be errors. Not really errors, because, a cropland would look almost similar to areas that are grasslands. So you need to be keen when you are selecting the training sites. I'm not able to identify them in the image. So planted to, okay, these are agricultural lands that changed to a forest. Then planted to cultivated. Planted to herbaceous. So what I'm looking for is the areas that changed from forest to other classes. I'm missing them here. Let me confirm this was, yeah, these areas, they were forests before. Add all values. It's missing, so maybe I'll run the change again just to check why it's missing this class. Or maybe just identify some of the areas. You see how it has classified them. Oh, there is a mistake here. Oh, the 1995 classification was done on a wrong image. Yeah, sorry for that. We need to repeat the 1995 classification. So let me remove this. I'll remove everything else that we are not using and remain with the 1995 image here. Okay, the 1995 image is here. I think we had already selected the training sites for 1995. So we just go back to imagery, classification tools, classify, and then we select training samples for 1995. This is okay. Here it's 1995, it's okay. Yes, so I can save it there. We give it a few minutes to run. There it is. Now let me export this to the folder where we've been saving the other classifications. Select the folder MAU classified 1995. This is version 1. Let me have version 2. I'll delete the rest. And then for the no data, it's 0. Click on export. It has exported successfully. Ah, okay, I have to check the training sites. Maybe they didn't say some of the classes are missing. We will go back to training samples, raster, imagery, classification tools, training sample manager. So these are the samples for, yes, they are there. For planted or cultivated, they are here. Herbaceous, herbaceous, I can't see them. Okay, they're here. Okay, fine. So the training sites are there. Maybe I'll save us another file, 19 more training 1995. Maybe I give it version 1 and save. So then we go back to run the classification. Imagery, classify, support vector machine. The training sites version 1, 1995. Leave this as default. Yeah, we can run it there. Okay, that is the classification. I can go ahead and do the change detection now that we have the two classifications ready. I should remove this. Okay, maybe I load the 2025 classification because I removed it. But if you didn't remove yours, then you just go ahead and use it. 2025 was version 1. Yes, I have the two classifications. Yeah, we go back to change detection. So imagery change detection wizard. There it is. We detect changes within the categorical change, yeah. Or categorical change. I think that's okay. From raster, you use 1995 to raster, it's the 2025. Then full extent, go to next. Those are the classes. Okay. We didn't change this. So filter method, you are either looking at the areas that changed only, or you are looking at all the areas, or you want to look at the areas that did not change. So in this case, we look at all the changes so that we are able to see everything that changed, what changed to what. And then you go to next. Okay, for smoothing, leave it default, save as raster dataset, and select where you want to save it. I'll save it here again, using the same name, but give it version 1, just to distinguish between the previous one that did not run well with this. Give it a few minutes. Yes, now we have our changes here. Yeah, so the area that I was interested in is this area because there were a lot of deforestation activities. So, for example, areas that changed from forest to planted, that is from forest to agriculture, if I give it red, we are able to see that. Yeah, now, so with this, you can be able to analyze what has been happening to the habitats. For example, you see a lot of forest was lost in this area, and this is a protected area. So it means a huge habitat for wildlife was lost. So after you've done your changes, then you can go ahead and do and calculate the area so that you are able to quantify how much of forest was lost and how much of forest was gained, how much remained intact, etc. Now, for us to do the area calculation, we will go to analysis and then click on tools, analysis tools. Maybe you can search area, generate area. Calculate area. Yeah. Sorry, it's called tabulate area. So there it is. So for tabulate area, input raster, you select your change detection. Zone failed value, it's okay. Eh? Okay, we are back. We are back. Yeah, so we continue with our we continue with area tabulation. So we had gone to tabulate area. So in the spatial, maybe I just go back. So go to spatial, go to tools, then click on spatial analyst or search, just search tabulate area. In the spatial analyst, go to zonal, then select tabulate area. Tabulate area. So for input raster, you will use the change detection file, the change detection image that we did. And then for the zonal field, we use from. Then the input raster, we use the same image, and then the zonal field, we use who. So that is from when to when. So these attributes, remember these attributes are in the image. So if you go to the attribute table of the image in the contents, you will see the classes, yeah? Class from and class to. So class from is 1995, class to it's 2025. And then the output table, remember whatever we are generating, its area that will generate based on the attributes of that, the change detection image. So, and the attributes will be written in a standalone table. So give it a name, or you can leave it default. And then the processing cell size, the cell size will be the same as the cell size for the classified image. And then you run. So it will create a table. It will create a table that will be displayed in the contents pane. In the contents pane. So this is the table. So if you open the table, just right click on the table in the contents pane and click on open. Oh, okay. I think I'll redo here. So I'll change the setting, check the class as rows in output table. Check this. Check this to ensure that all the records in the classified image are reflecting in your resultant table. And then you will have to change the name. If you already have the table, you'll have to change the name so that it is able to write the table again. So click on run. Yeah, the table is there, table 3. So right click on it and open. Yes, now you will see your classes. So we have class from and class to, and then we have the area. So remember, this image, if you look at the projection of this image, just right click on the classified image, click on properties, and under the layer properties dialog box, click on source, and then click on spatial reference. So you'll see that the image is in UTM, WGS 1984, UTM zone 36 north. So for UTM, the units are meters. Now, if you want to, so this area is in meters. If you want to have it in hectares, then you need to calculate the area in hectares based on this. You need to convert from meters to hectare. If you want your area to appear in kilometers, square kilometers, then you need to convert from square meters to square kilometers. So this area is in square meters. So if we want to calculate maybe the area in square, in hectares, for example, you need to add a field. You need to add a field to this table, and then you calculate that area within that field. So click on add field, and then give it a name, for example, area underscore HA, that is hectares. So for area, the field type is double. So double means it allows for decimal places, for decimal data that has decimals. So once you do that, you can click on save in the toolbar above. So click on save for it to save the table, the field that you added. Now, your field will appear here and it has null values. So what you do, if you want to populate the area, you use the same concept that my colleague Eric took us through of updating fields. So right click on the field and then select calculate field. So in the calculate field dialog box, you can choose the language that you want to use. So remember, you have Arcade, you have Python, you have SQL, you have VB script. So we can decide to use either Python or VB script. If you use VB script, I've decided to use VB script, but you can use any. So we want to convert the area, the values that are in a field called area to hectare. So you double click on the field. Under fields, double click on area, and then to convert from square meters to hectares, remember 10,000 square meters form a hectare. So we will have to divide the square meters by 10,000. So double click on area and then slash. So slash means division, and then just type in 10,000. And then apply. So if you look at the table, then click OK. If you look at your table, it has computed the area in hectares. So at this point, you can export this table to maybe open in Excel. You can export the table as DBF and open it in Excel. You can as well copy, select everything, copy and paste it in Excel for further analysis if you wish to analyze with Excel. But with this, you have everything here. You know how much forest did not change. That is the first record, maybe around 52,000 hectares. So again, class from, it's 1995. Class 2, it's 2025. If you want to have one column with the changes, you can still add another field. Need to save the table. Okay. need to save the table. Okay. Add field. Don't know why it fails. Okay, yeah, there it is. So you can add another field. Just click here. Maybe I need to repeat. While still in the attribute table, in the standalone table, you click on table in the toolbar, and then you'll see an icon here, field. So click on fields. It will open this table. Once it opens this, down there is click here to add a new field. So just click there and call the field maybe change. So for change, you want to calculate the changes, so we can, you change the field type to text. Text is string text, and then save. Yes. So once you save, just close the fields. The field is there, it has been created. So we can now calculate the class from and class to and combine them in the change field. So to do that, just right click on change, right click on the field, and then select calculate field. Once you are there, again, I will use VB script again. In the change here, in the box here, where there is change is equal to, double click on the first field, which is class from, so which is representing 1990. Type comma, and then type opening quotation marks, space, then type 2, space again, and closing quotation marks. Oh, sorry, you need to add ampersand here. Ampersand is this sign here. Where is it on the keyboard? That sign. Don't use comma, use ampersand. I don't know, it's called and then type, click on class 2. So it is class from ampersand, quotation marks, opening quotation marks, space 2, space, close the quotation marks, ampersand, and then class 2. Then click on apply, and then click on OK. So if you look at your attribute table, it has populated. Now you have the changes: forest to forest, forest to herbaceous, forest to planted. Now you have the changes clearly, and you have the area. Yes, up to there. I wish to stop there and invite questions. Yeah, so I will invite questions. Just a minute. Okay. Okay, Aota Bear.
Hello.
Yes.
Yeah. Mine is just I want a clarification. I've tried my level best to create a shapefile using ArcGIS so that it should be added to the Earth Explorer, but I'm failing to do so. I went to the catalog pane, but I don't know where to click so that I should create a shapefile that has an extension of SHP. Yeah, thank you.
Sorry, come up again.
I'm saying I want to create a shapefile that has an extension of SHP to be added in the Earth Explorer. Yeah, but I've tried my level best, but I'm failing to do so. So I need the clarification.
Know how to create a shapefile.
Yes.
Okay. So, or is it okay? It's a question that is not linked to session. Is it true?
Yes. It's not linked to this today's session, but I think on where's this?
Yeah, I can still show you how to create a shapefile.
Yep.
So okay, so let me show you how to create a shapefile. So a shapefile now, maybe let me add a new map here so that we use a new, okay. And probably add an image, maybe from the same area that we have been classifying. Stack 2. Okay, so maybe we want to create a shapefile for this area. A shapefile that we can use maybe to digitize a few features from this. So for you to create a shapefile is created in what we call catalog. So you need to open the catalog pane, which is found in the View tab. So go to View, and then look for Catalog pane. Not Catalog View, Catalog pane. So click on Catalog pane. It will open on the right. So in the right, you need to go to a folder where you want to save your shapefile. For example, in this folder, the folders here, if you click on it, it will show you the folders that are connected to this. If your folder doesn't appear here, right-click on that folder and select Add Folder Connection. And then navigate to your drive and select the folder. For example, I would select this. Yeah, once you select it, it will appear there. Now, all the files within that folder, you'll see them. Now, maybe let me use this training folder, then data. I can save it. Where do I save it? Maybe in boundaries. So let me save it here. So if you want to save your new shapefile here, you need to right click on that folder, select new, and then click on shapefile. So it will open this dialog box where you need to give the name to the shapefile that you want, maybe MAU features. I'll call it MAU features, for example. And then the geometry type. Remember, in vector data, we have three geometry types. So we have polygons, we have lines, and we have points. So if we are to digitize a river, for example, we will use polyline. If we are to digitize points, schools, maybe within the country, we will use points. So it now depends on what you want to digitize within the same shapefile. So for now, maybe let's use polygon. Polygon. And then for the coordinate system, you need to select based on the area that you are working on. The projection system that works, but I would recommend you use WGS 1984 because that one applies worldwide, anywhere. But for this exercise, let me use a similar projection to what the image is projected in. So just click on this arrow and select the image. It will read the projection of the image, which is WGS UTM. Once you are done with that, just click on Run. It will create the shapefile and load it in ArcMap, in ArcGIS Pro. So you'll see it in the contents pane. So here it is. Now you can change the symbology of this shapefile. Just click on the symbol and maybe select outline black. So once you select the outline black, you can change the color of the outline to whatever. Maybe let me try yellow and see. I'm using yellow. So once you do that, now you need to digitize features into that particular shapefile that you've created. So just go click on the shapefile and then go to edit and then click on create. So create. It will display your shapefiles here. So click on that shapefile. It will give you the tools that you need to digitize the polygons. So for example, we want to digitize this as a polygon. So I'll select this tool here and start digitizing. Once you are done with the digitizing, just double click or click and click on the tick. So I like double clicking because it's fast. No, don't click on the tick, just double click, sorry. You want to digitize another feature, for example, this one, just go ahead and digitize because the tool is still active. You can digitize as many as you want and then click on the tick. So clicking on the tick means you are done with digitizing. Now you need to save your edits. So click on Save Edits. It will save. Now, if I remove this layer, the layer that we created, and load it again, add data, go to the folder where we saved, it was boundary, and then refresh. So you see more features is here. If I click on it and load, you'll see your features. You already have a shapefile. Have I answered your question, Aota?
Yes, you have tackled it well.
Thank you. So we go to Teddy Namazi. Is it Namazi or how is it pronounced? Teddy, unmute yourself and go ahead. Teddy? Okay, maybe I'll move to Jessica.
Yes, thank you so much for the presentations and the all effort you put into to take us through this training. I wanted to ask about the support after this live session because I think this is the last one. This last session, yes, was a bit intense and was difficult to follow everything properly. So, yesterday I saw some comments from colleagues that they say that the option that extract by mask was not active. So if I go through that to do the assignment, for example, using the recorded videos, and I face the same challenges, how I'm going to let you know or to report that, because also I'm seeing that the time is also the arm of the ending it is coming soon. So thank you so much.
Okay, thank you, Jessica. Yeah, so I know that it has been intense. So we will upload the recordings and then you'll be able to follow. And then your question about the support. Yeah, we are still available to support you. Just continue engaging us in the community and also in our emails. That's coe@rcmrd.org. We will continue supporting you. And then maybe for the extract by mask, you said some are saying that it's not active. Did you say that it's not active?
Yes. It was like that, and there's a guidance from the I think it was ICT was helping here, and after that was the one that got active.
Or it got active? Okay,
no,
maybe I can
I'm
just
saying it
yeah.
was not, but then after report and then share the details, it got active.
Okay. Okay. So you've been able to get a solution to that, yeah?
No, what I'm saying is I saw here, like I'd not be able to follow, but it was a comment like some colleagues had that these challenges. So I'm asking, in case I have the same challenge, like when I'm doing my practical and I need to report so that I'll be able to active that option.
Yeah, we Okay, so I understand why it was not active. I've understood it was on our end because of administration of the software, but the issue has been sorted. So I'm just hoping everyone is able to have it active. So in case you face such a challenge, kindly just reach out. We will be able to sort you.
All right, thank you.
Okay, thank you. So I'll move to Edward.
Christopher, this is very great. I really appreciate what you guys are doing. It's really adding value to some of this work, some of us we are doing, and especially assessment of the protected area changes is very, very important. I still follow up on the accuracy assessment because it is also very important, because some of these products that are generated are supposed to be recognized scientifically. Now, as much as due to some errors, we failed to execute accuracy assessment, I know with the use of the videos, we are going to follow and execute. I'm certain in that. The only thing I'm trying to reason and try to understand, and I would like you to help me understand the algorithm behind the accuracy assessment. For example, under conventional kind of approach, if you do assessment of accuracy for the report to be out, it is comparison between a classified image and the ground verified points. Now, for this case, we are talking about historical maybe data where you cannot go on the ground and find exactly what is there. Now, how does this algorithm work? Because I think if it was done to the end, I could try to understand. How does it, what these points, how are they comparing? How are they comparing these points to ascertain that instead this is accurate, this is not
Okay.
accurate? A summary. To use this skill sometimes, and I will be asked questions. Thank you.
Yeah. Thank you, Edward, for the comments that you gave. And then just to address your question, maybe I'll briefly explain about the process of accuracy assessment in this platform. Now, the process is when you create the sample points, and then the sample points requires ground truth data. So ground truth data, remember we said ground truth data can be collected by different means, even though I know Leonard will say you have to go to the field, but I know when you have images with very good resolution, you are able to see what is on the field, what is on the ground, and you are able to use that. So what we do, once you have the points, the accuracy assessment points, now you can go ahead and get ground truth data, whether you went to the field and collected the data, or you can still use high resolution images to populate the accuracy assessment points. For 1995, you see, we cannot go to the field right now to know what was there in 1995, but we try to use what we call Google Earth. Maybe let me just share again and show you Google Earth. So this is an app that you need to install, and I'm sure, Edward, you've interacted with it a lot. So when you are in this particular software and you want to check what was there in 1990, so you click on this block here. So it will give you a slider where you can slide between 2025 and 1973. So you need to confirm whether there is any data for 1990 because it might not be there. So this is 1985. So if your point is falling here and you are looking for data for example, for 1885, you are able to know maybe what really was there. So it might not be the best, but for the past years, this can act as a guide. Remember, it is a guide because you have used a remote sensing image with a coarse resolution, and it has told you that this is a forest. If you go to Google Earth for the same year, it tells you that there is a high probability that it was a forest. Then for me, I would say that is a forest. But if, for example, this is 1985, is it 85 or 95? So, and this area looks like it's not a forest. So there is no way I could doubt that if the image with the coarse resolution that I'm using indicates that it's not a forest. So this is just a guide to guide you on what is there, what was there before. Now, maybe on the same note, when you are interpreting this image, maybe I didn't mention that, and I've just realized that it is critical that I mention because it might guide someone. So when you are interpreting this image ready for classification, you can click on this base map and click on either hybrid or imagery. So it will load a base map. It will load a base map, and this base map can be used as a guide. You can use the swipe tool. So the swipe tool, we said it's you click on the image and then click on raster and then the swipe tool. So when you swipe, you are able to see what is beneath that particular image. For example, this area, you're able to see that it is cultivated. This area, you can see that this is it's not cultivated, but it's kind of a grassland. So it will act as a guide. You should not entirely depend on it for interpretation, but it should guide you on what is probably at that particular point. For example, look at this. The spectral reflectance here, it's a bit different from here. If you swipe, you'll see that this looks more like a grassland on the base map, including this. Yeah, so this, and then look at this area. So the image is for 2025, the Landsat image, but look at what is there. This one looks like these are forest, but when you check, it doesn't look like a forest. So it doesn't mean you doubt your Landsat image because the base map says that it's not a forest. The base map was to guide you, but you are the one interpreting. Okay, Edward?
Please,
don't know whether I've addressed here. Yes.
It means, because I thank you for that. I have used the Google Earth before, meaning it's the same concept that the model uses to do accuracy assessment.
Yes.
You can confirm that.
Yeah. So for the model uses the ground truth points. So it is you to interpret. In fact, it is you to feed it with information. So you will tell it that on the ground, this is a cropland. On the ground, this is forest. On the ground, this is grassland. And then it will now compare with what is classified in the image. So it is you to feed it with the right classes on the ground.
Okay, thank you very much for that clarification.
Okay, thank you. So the next person is the next one is maybe let me stop sharing. Oh, Margaret Wangare.
Hello.
Yes.
Thank you for very impactful lessons. I wanted to inquire, in case, do you guys offer face-to-face online, not online, face-to-face classes? And if you do, how much does it cost? Because the online class is very helpful, but I think also having that course done face-to-face can be very helpful as well. And how long does it take if you offer it? Thank you.
Okay. Thank you. So maybe we as RCMRD offer courses. I might not be able to. Okay, let me give a chance to Isaac. Let me give a chance to Isaac to address that. Isaac, go ahead. Isaac, unmute yourself and go ahead.
Okay, thank you, Chris, for the opportunity. So we are glad that you are interested in our courses. So we have our institution offering these courses in 3 categories. So we have the professional courses, which are normally advertised on our website through Opportunities tab. And that can be done based on the training calendar. So when you visit our website, www.rcmad.org, under training, under opportunities, you'll find our training calendar. You can check and book which trainings you are able to attend at that specific time. Another type of training we offer is the tailor-made. So for our case here, what we've been offering was a specific course. So if you find that there's a course that you need, and then within that course, you don't get really what you wanted to be taught, you can be able to tell us which aspects do we remove and which aspects do we add, so that we cater for your course needs fully. And then the last one is an in-house. So an in-house happens whereby as an organization, you might be having like 20 people want to be trained, and bringing them to RCMRD might be an inconvenience. So we normally opt you inviting us to your premise, we can be training you from there. So if you're like in Uganda or Tanzania, we can be able to arrange for that training so that we come to your place and train you from there. So I'll encourage you to visit our RCMRD website. Under the opportunities, you'll find our training calendar. So you can be able to interact with it and book some of the openings. So they're normally 2 weeks to 1 month training based on the needs of the client. So feel free. I think that's okay, Chris. Over to you.
Sorry, I was mute. Thank you, Isaac, for that elaborate explanation. I don't know whether, Margaret, are you satisfied with the response?
Yes, I am. Thank you.
Thank you. So the next will be Ibrahim Ambale. Are you ready now? Unmute yourself and go ahead. Okay. If Ibrahim is not ready, Brenda Kamara.
Can you hear me?
Brenda? Brenda Kamara, we can't hear you. Maybe we go to Brenda. Brenda seems to be having some technical issues. Okay. Haile Jesus. Haile Jesus Segao.
Hello, everyone. Can you hear me?
Yes, we can hear you.
Yeah, just. Hello, can you hear me?
Yes, yes.
Yeah, I just want to say, thank you. You have been a lot through this 1 month. Even you try to extend for extra time, one week. So I really appreciate your time, your effort, and your energy, the commitment you have, and the platform you created. Even for the person who cannot attend, even you made a video. So all the documents and your commitment is really an inspiration for us. I just want to take this opportunity to appreciate. Thank you very much. That's all from my side. Thank you all the team.
Thank you, thank you, thank you. Brenda, are you ready now? Brenda Kamara, unmute yourself.
It's not working. Hello?
We can't hear you. Maybe I would advise you type in the chat because we cannot hear you. So Ibrahim Ambale. Ibrahim has gone. If you are ready. Ibrahim has gone. So I think we don't have further questions. Okay, Ibrahim, yeah, I can be able to see your questions. So, okay, Brenda. Your question is on the formula to effect change. Are the formulas inbuilt? No, you need to type in the formula. So you need to type in the formula, Brenda. They are not inbuilt. But the fields, remember we double clicked on the fields, on the two fields, and then we typed in something in between just to connect the two fields. So the fields are the fields are already in the system, so you just double click on it and it will indicate in the code block. So the formulas are not inbuilt, you type in. So Ambale, your questions, are we allowed to maybe share on platforms like LinkedIn or on our portfolios, the work we have done, e.g. databases? Yes, it's good to share. Go ahead and share what you've done. I've seen some of the participants have been sharing, and the products that they have been sharing are very awesome. You guys have done very good products, very good story maps, very good dashboards. So just feel free to share on LinkedIn or whatever platform you would wish to. And then the other question is, can RCMRD provide us with challenges that we can participate in, or rather, we can volunteer in some works? Okay. Okay, that question will be addressed by my colleagues. Yeah, so we have several opportunities, Mr. Ibrahim. So some of them are training opportunities. Some of them are like we have a map competition that is currently on. You can participate and continue following our social media, our social platforms for more information and for more events that are ahead. Also, our Geo portal, we usually update events, and RCMRD website. So JM Josiah Matthew, I sincerely thank you for the valuable training session. The knowledge and skills gained will greatly contribute to my professional growth and future work. I truly appreciate the effort, time, and dedication you put into making the training engaging and impactful. Thank you for the kind words, Ibrahim, Josiah. Yeah, we are happy that we've made an impact in you. Yeah, so I think up to that point, I wish to end there and welcome the next and very final session. Yeah, the next and very final session, just to wrap up the training and close the training officially. So maybe I welcome my colleague. Yeah, I welcome my colleague for the final session. Thank you. My name is Christopher Mudavi. I'm a GIS Seascape Ecosystems expert at RCMRD. Continue engaging us on our platforms. We will still respond to your issues throughout the training sessions and even beyond. Thank you.
Okay, good afternoon, colleagues. Kindly confirm if you can hear me. Yeah, so my name is Michael Ngugi Kimani. I'm here to do the final wrap up of this particular training. It has been quite a long journey since we began on 11th of August. We can't imagine that it's already four weeks since we started. Maybe just to quickly mention, I know one of the comments that we have been receiving is on the issue of the license. So this is just to share some information about some of the programs and some of the opportunity and some of the licensing options that are available for you after the training. One of them is that we have, through our partner, Esri Inc., they have various programs that that you can access in the different platforms that they have in their website. They have conservation programs, education program, disaster risk program, and also non-profit programs. So if you are doing an activity and you want to see some of the initiatives that are along that line, please visit their website and you'll be able to access that. Then in terms of the licensing, the license that we have been using for this training is going to expire on 15th of September. So please ensure that you finish your training or your practicals before 15th of September. And then in case you want to do your own research or you want to continue with engagement much later, you can visit the Africa Geoportal website, and we'll share this link much later. The Africa Geoportal is a place where you can access a free license. You can also go to the Esri website and download the trial licenses, so you can be able to take advantage of all that. Perhaps just to mention as we wind up this particular session is that the next step that we shall be having is, of course, to consolidate all the comments that we have been having. We know there's still a community of people who will be finalizing the training up to perhaps next week. We will be engaging with them. We also would want to announce that we shall be having the next online training from November 17th to November 28th. We have noticed that there was quite a huge interest on ArcGIS Online, dashboard, story maps. We had some requests on the ArcGIS Hub. So we are packaging a training that will be for 2 weeks, running from November 17th to November 28th. Please watch out for it. We are also trying to see if we can liaise with our partner to see if we can get the license for a longer duration. Instead of it being for 1 month, perhaps we'll get a license, each participant will get a license for around 6 months or so. So those are the next steps that we do have. So from RCMRD and the entire team that has been behind this training, we would like to wish you the very best in the training that you have been conducting. We hope that it has been worthwhile. I know at some point it was quite overwhelming in terms of the numbers that we had, but we decided to proceed nevertheless. So colleagues and friends, we learn from each other. We have also learned a lot from you. We have also grown in terms of what we have been doing. If it was a physical training, today we would be having a graduation. Perhaps we'll find time and see how we can do a virtual graduation at some point. So from me and the entire team from RCMRD, once again, this is the end. We'll meet again on November 17th when we shall be having another training on this beautiful technology of geospatial information services. We hope that when we meet next time, we'll be having a better package than perhaps what we even have right now. Thank you very much. That's it.